as a professional elective 6 in the 4th year second semester. So coming to the geo-environmental engineering. So in this course, so actually it consists of two main prerequisites, like geo is nothing but which is dealing with any earth, I can say, like any ecological materials and all. Geo, and environmental is nothing but anything dealing with the ecosystem or the environment. So the both put together is called as geo-environmental engineering, and prerequisite or the subjects, prerequisite subjects for this course is the environmental engineering, which you already learned in your 4th year, and also soil mechanics, or I can say geotechnical engineering. And in some of the other institutes, they have given the another name for this as like geotechnical environmental engineering, or geotechnical environmental. So coming to the keywords of this geo-environmental engineering, so mainly the keywords you see in the complete course is like what are the different geotechnical aspects related to the waste disposal, and later on what are the design for the landfills, slurry ponds, and the source of contaminated sites, and also some remediation techniques also. So these are some of the keywords you may come across during this course. And as per the academic plan given by the JNTUH, so this course will be completed in 12 weeks. So 6 weeks is the first part, that is before your mid 1, and another 6 weeks after your mid 2. So coming to the syllabus as per the JNTUH course structure. So here you can see the B.Tech 4th year second semester, and the course code is CE 862 professional elective. And as already mentioned, the prerequisite subjects are soil mechanics and environmental engineering, which you already learned in your previous years. And these are some of the course objectives and the course outcomes. That is, objective is nothing but what you are going to study in this course, and at the end of this course, what the student will be able to make out from this course. And the syllabus as listed in the JNTUH course structure, you can just go through. So here what happens, total 5 units, and also have put another slide here showing the taxonomy levels. So like here in the syllabus content, like in unit 1, you are mainly going to study like unit 1, and along with unit 2, you will be mainly studying some of the aspects which is again linked or interrelated to the course which already studied, that is environmental engineering. And coming to the other, that is unit 3 and unit 4, there you are going to study some of the topics which is related to the soil. Like you can see, like whatever the soil got contaminated, and what all the remediation techniques should be adopted for removing those contamination of the contaminated soil, I can say. And unit 5 is all about the landfill, types of landfill, and what is the site selection process, and what are the waste contaminant liners should be adopted, and leachate collection system, and what is leachate. That all we are going to study in unit 5. So I can say the first 2 units is completely is all about environmental engineering aspects, and unit 3, 4, 5 is all about the soil mechanics or geotechnical engineering aspects. So this was just a brief introduction about the syllabus. So this is the syllabus from the JNTUH curriculum, that is JNTUH's course structure. So this I will be sharing with you through the Abhyas portal. So as of now in the Abhyas, I have not created any course, geotechnical engineering course. So once I create it, I will add all the students who have opted geotechnical engineering course in this semester. And also I'll be sharing these PPTs in the form of PDFs in the Abhyas. Okay, so moving to the, so here I've written the taxonomy level. Taxonomy level is the level of knowledge we'll be gaining and like apply. Usually we come across 4 to 5 taxonomy levels. So mainly the first two taxonomy levels are the basic taxonomy levels like TL, taxonomy levels like understanding and knowledge. And the third taxonomy level is apply. Since this course is already what you have learned in your previous years, that is soil mechanics and environmental engineering, whatever like soil physical properties of soil, physical properties of water, in environmental engineering. So those all whatever you have learned in your prerequisite subjects are applied in this course. So that's why all the taxonomy levels of all the units will remain as applied. Whenever it comes to any analytical subject, there we usually take as analysis as the taxonomy level. Since it is completely a theoretical subject, so the taxonomy level for all the units remains the same. So usually in your bid question paper, you may be seeing the taxonomy level just to know what are the taxonomy levels of the units. For that, since it is an introduction class and a syllabus class, that's why I want to go with all the things related to the course. And moving to the course objectives with reference to what are the syllabus I have pointed out before in the before slides. So here you will be gaining the knowledge on a various source of contamination of the ground, and also what are the site characterization and what are the different methods of site characterization in the first unit. And coming to the second unit, we will be getting the knowledge on the various type of contamination and what are the environmental strategies to be applied for this contamination. And later on, third unit is all about the contaminant transport process. And fourth unit is all about whatever the remediation techniques, as already I mentioned you, whatever the contaminated soil is there, what are the remediation techniques to be adopted for those contaminated soils. And fifth unit is all about the landfills, the types of landfills, site selection, right? So those were the course objectives, what knowledge you are going to gain from this course, that is Geo-Environmental Engineering course. Coming to the course outcome, that is with reference to the syllabus and the taxonomy levels defined, what are the outcomes, means what the student will be able to get it after learning this course is like I have listed out here. You can just go through, like the student will be able to identify the sources of contamination and the need of site characterization, right? So whatever you have seen in the objectives, the same objectives are repeated here, but we will be pointing out in the terms of outcome of the course here. So similarly, you can just go through the outcomes here of unit 1, unit 2, unit 3. So see your course outcome here, unit 4 and unit 5 here, right? So moving to the what are the new capabilities or the opportunities you may get in the future after studying this course. I just want to list out some of the opportunities you may get after learning this course, because it is very important. We usually start the course. The subject teacher starts the course. He explains the syllabus. He explains each topic of the unit, and he also explains the previous year question papers and everything. But you should know why I have learned this course and what are the opportunities in the future I may get after learning this course. In the future, if you go to any construction site, like as a project engineer or a site engineer, or if you go to any consultancy firm, anywhere. So this subject, whatever you have learned in your B.Tech level, that should be make use of there, right? So like here you can see the first point is all about be a part of a design team in any environmental consultant's office. So in a design team, so you know, in any of the consultant's office, a separate design team will be there. You can be a part of that, and whatever you have learned in this course, the same can be applied there, or the same can be used there, I can say. And the second point is be a part of the evaluation team for a regulatory authority. Evaluation team is nothing but like checking the quality of a water or any contaminated soil. What are the methods or remediation techniques to be used to overcome those contaminated soil? So evaluation team will be taking care of those things. And moving to the Next is, and also that is after your experience, you can also be promoted to a project lead or a project head for executing any project on landfills and slurry ponds. See, slurry ponds is one of the main aspects nowadays going on, because slurry is always produced in any of the industry. If you take any steel industry, there whatever the or steel industry or any coal mining or anywhere you go, slurry is being produced, and that slurry may be just thrown out in or thrown out, or it can thrown out, or it may be put on any empty areas and all. So because of that, some big deposition is been taking place. So that is happening. So whatever the slurry ponds and landfills are there, so those constructions and operations, so those projects also there, this course will be helpful. And moving to the last is, whatever the undertake analysis of failures and remedial actions at a waste dumps. See, nowadays what happens nowadays in Hyderabad city also, they have planned, or they have constructed a separate waste dumping plant, I can say, where usually the construction waste or any demolition waste in any construction site uh, will be taken care by those waste dumping plants, I can say, or any construction and demolition waste plants. So what they do nowadays, wherever the construction going on, or wherever the demolition or the whatever the changes of the building or renovation of the building is happening, the waste is being produced. Those waste should be sent to the some waste dumping plants, or this C&D waste plants. So that is being taken care by the government of Telangana, and also they are paying the construction site owners or the contractors for giving the waste material. So that is, nowadays they are moving to an sustainable development aspect, because nowadays whatever the waste material we are producing, we need to recycle them, and that recycled material should be used as a raw material now. Because of very scarcity of a raw material, whatever the waste material are there, that should be recycled and should be used as a raw material. So that's what, like, undertaking the analysis of failures and any taking remedial actions at waste dumps, landfills, slurry ponds, and contaminated sites. So in those places, this course, whatever you are learned, can be helpful. Right. So moving to, these are some of the prescribed textbooks and reference books I can suggest. So as of this course is actually new. This course is been opted is been opted or is been given in most of the NITs and IITs institutions which I've seen, and also the JNTUH has also taken up providing this type of course in the professional elective for 4th years. Because once if you study these this professional into courses in your 4th year, if you are interested for going further for your master degrees in environmental engineering or geotechnical or soil mechanics, so there this type of courses will be again given as a subject there. So it will be helpful for you again there. So since there is no particular textbook here, and also no particular textbook is as of now is available in the library as of I know, because I have visited the library and I gone through many of the textbook. There is no particular textbook, and but I have some of the soft copies like this, whatever, like geotechnical and geo-environmental engineering handbook, that is Rovi and RK of 2001 edition. So I have this textbook. I have two more textbook, maybe yeah, this one that is, yeah, geo-environmental engineering principles and applications. So I'll be sharing the same textbooks in your Abhyas portal, so you can just download from there. And these are some of the other textbooks. So the Indian authors like geo-environmental engineering, Sharma HD and Reddy, and KR 2004 edition, and the publisher you can just go through. So this is for your reference. If you want to get it from any of the online platform, you can just get it. So textbooks, and these are other textbooks also, which can also be used as a reference books. You can just go through. I hope I'm clear about the course objectives and later on the outcomes and also syllabus. So don't worry, this subject is completely about the theory, and also I will be discussing immediately after each unit. I'll be discussing the previous year question papers also, which are already available with me. And as per the previous year question papers, so he has asked a direct questions, usually like I can say like scope of geo-environmental engineering. He has asked for 15 marks in unit 1, and also what are the sources of the site character, oh, sorry, what are the site characterization and its applications, and explain any two site characterization methods and all. So I'll be discussing the same immediately after each unit. Right. So this is the question bank. So whatever just I have presented here till now, that is the course objectives, outcomes, and syllabus, and this question bank is all is been taken from the academic plan, which we have already created, or which are already planned before this course only. That is in the previous semester itself. So these are the question bank. You can just go through for each unit. I have given the total 8 questions here, so you can just go through these question bank. So this question bank is like from these questions only I may give the assignment questions and tutorial questions also, and unit 3. So each unit I have given 8 questions. So unit 5 I have not included here. I'll be adding the unit 5 questions also, and I'll be circulating among you through Abhyas. Yes, so I'm moving to the next part here. That is, I'll be starting unit 1 without not wasting much time, because of very less time I can say. So this course has to be completed within 2 weeks, as I already said you. 1 week before your, that is 6 weeks before your mid 1, and 6 weeks after your mid 1. Right. So moving to this first unit. So as I already explained you, what is geo-environmental engineering? Geo is nothing but dealing with the earth, such as any ecological matters, anything, and environmental is related to the environment or ecosystem. And these are some of the keywords you may come across in this course. That is geotechnical aspects of waste disposal, design of landfills, slurry ponds, and contaminated sites. Right. So moving to here, just I want to start with a quotation which has been given by ASCE. So ASCE is one of the reputed journal and also publisher, I can say, American Society of Civil Engineering. So as per the ASCE, so he is saying engineers have a significant role in planning of any structure, I can say, or roads, or designing, building and maintaining a sustainable future. So sustainable future is nothing but whatever the present resources are there, that should be utilized, and it should also be preserved for the future generation. And after that, we provide the bridge between the science and the society. So that's why whatever we consider the technology and the science, that should also give a sustainable society, I can say. So in this role, we is nothing but engineers must participate in interdisciplinary teams, applying technology to the issues and challenges that require environmentally sustainable strategies and solutions. So whenever we participate in any of these interdisciplinary teams, I can say, or applying the technologies, we should always take care of the environment by applying some issues or challenges or techniques which is required for an environmental sustainable strategy, or which is applied for preserving an sustainable future, I can say. So before moving to the unit 1, that is unit 1 is all about the waste disposal and all. So I want to discuss about the sustainable development. So sustainable development, a simple word, we can say it as geotechnics. So here sustainable development is nothing but like any energy utilized the help of water and soil and making use of the natural resources, which leads to any productivity or production in any industrial I can say, or in any agriculture and food production and urbanization. So industrialization is nothing but whatever the development of new industries in any country or a region is, we say it as industrialization. Agriculture and the food production after the agriculture, and urbanization is nothing but the movement of peoples from the rural areas or villages to the urban areas. So because of this industrialization, urbanization, what is happening? There is a more usage of natural resources, and also these natural resources, maybe I can say it as fossil fuels or any sunlight, wind, and all those natural resources are utilized in some or the other way, and energy is been applied, and while using the natural resources, we may make use of water also, right? And at last, all this leads to the production of some goods and services. And at last, we should see that any production of goods and services we do should have, whichever reaches to the society, should provide a good sustainable society, so that sustainable development is taken care. So before moving to the course, I just want to recap all the basic things like physical properties of soil. Like here, what are the physical properties you may have come across till now in your soil mechanics? I can say like soil texture. So soil texture is nothing but the composition of the soil particles. It may be, I can say it as composition of soil particles like gravel, and later on sand, and later on whatever the silt and clay, right? Silt and clay. So depending upon the composition of these soil particles, you may be telling the soil type. And later on the soil structure here. So soil structure is nothing but whatever the soil particles present, what is the shape of that. So depending upon the shape, we will be defining the soil structure there. And soil color. So depending upon the color also, you will be naming the soil, like black cotton soil, black in color, red soil, red in color. And later on soil porosity. So the pores present in the soil. So mainly the pores in the soil are mainly because, I can say it as because of the roots of the plants penetrating into the soil. Because of that, some of the pores are produced in the soils. And later on soil colloid. Soil colloids is but some of the particles which are not separable by any ordinary filtration. We say it as soil colloids, like any plastic mixed in and soil, plastic or any paper, or any foreign particles, I can say. So that we say it as soil colloids, which are not separable by any ordinary filtering method. Coming to the next is physical properties of water. So physical properties of water, like water temperature should be taken care, and turbidity. So turbidity is not visible to our eyes. So we should determine the turbidity of a water through a proper method. And water color, blue we say, and with later on light penetration. So whenever the light comes on the water, usually it may penetrate through the water, or it may be reflected back into some colors, we can say. And later on chemical properties of a soil. So till now I discussed the physical properties of soil and water. So moving to the next is the chemical properties of the soil. So whenever I talk about the chemical properties, so here we should mainly think about the soil pH, which will be usually between 6.5 to 8.5, I can say. And later on organic matter present in the soil, calcium carbonate present in the soil. Soil salinity is something, but usually the soil will be mixed with the salt, some of the salt content, that we usually say it as soil salinity. And redox potential. So redox potential is one of the chemical property of a soil, where we usually talk about the electrons present in the soil. So these electrons will usually help in the any inorganic or organic reaction taking place. So whatever the electrons present in the soil, so that can be easily determined from the redox potential in soil. And later on, CN ratio is nothing but the carbon nitrogen ratio. And later on, nutrient status. So nutrient status is nothing but usually the soil which is beneath the roots or beneath the plant will usually consist of nutrients. They are nutrient rich, I can say. And coming to the next is chemical properties of water. So you have seen the chemical properties of soil. So now moving to the chemical properties of water. So in the chemical properties of water, basically you should know what is dissolved oxygen, because whenever I talk about the dissolved oxygen, whatever the amount of whatever the gaseous O2, that is oxygen, which is dissolved in the water, is important. And carbon dioxide. So whenever I talk about the carbon dioxide, so the carbon dioxide should not be present in a water, because if it is present in a water, we say it as it is a carbonic acid. And coming to the pH, you know, 7 is the neutral value. So less than 7, we say it as acidic, and more than base or basic. And later on, alkalinity. So what is this alkalinity? So whenever we talk about the chemical properties of water, we usually talk about alkalinity, hardness, and salinity. So alkalinity is nothing but whatever the measure of the ability of the water body. So any water body you take, so we need to measure how it mobilizes the whatever the acids and bases present in the water. We say it as alkalinity. And coming to the hardness here, so hardness is all about whatever the dissolved calcium and magnesium in the water. So that we can come to know from the hardness. And salinity, as already said, whatever the mixture of salt or the presence of salt content in the water. And hydrogen sulfide. Hydrogen sulfide should not be present in the water, because it should be taken care because of whatever the sewage pollution, because of the sewage, whatever the pollution happening. So because of that, hydrogen water may get into the water. So that should be avoided. Hydrogen sulfide presence in the water should be avoided. Like H2S, we said hydrogen sulfide is nothing but here H2S. So this H2S, that is hydrogen sulfide presence in the water, should be avoided. If it is present, we may get some foul odor of any egg rotten, that type of foul smell we may get. And it is also flammable, and it is poisonous also. That's why we should see that hydrogen sulfide is not present in the water. And as I already said, redox potential is nothing but the presence of electrons, which is again helpful for the any organic and inorganic reaction, electron present. And ammonia is actually it should not be available in the water, because it is non-toxic to the humans, but it is toxic to the aquatic animals. So that's why ammonia should not be present in the water, which is usually harmful or toxic to the aquatic animals, I can say. Right? So what is the role of soil? So till now we have seen the physical properties of soil and water, chemical properties of soil and water. So moving to this, what is the role of soil in this geotechnical engineering applications? So whatever the civil engineering structures, like buildings, you can say, or roads, you can say, are ultimately founded, or the soil is one of the base, is one of the lowermost layer or foundation for any civil engineering structures. And the soil stability mainly depends upon the geotechnical properties of the soil, and these geotechnical properties may be disturbed by any contamination. And third point is, soil is an efficient load-bearing stratum. That's why soil is used as a foundation for any civil engineering structures. And foundation transfers these whatever loads coming, maybe the loads coming from the buildings or the loads coming from the roads, that is from the vehicles moving on the roads, is efficiently transferred to the subsurface. Right? So moving to the need for geotechnical engineering. So to look into some of the issues which are ascertaining the quality of air, water, and land resources, and also whatever the transport mechanism, that is whatever the waste material are there, whatever is being disposed, how to transport, use, and disposal of those hazardous waste material. So these are some of the issues which will be looked into this geo after learning this geo-environmental engineering. So that comes under the need for geo-environmental engineering. And later on, whatever the water and wastewater treatment and its reuse. And the fourth is about the analysis and design of any foundation system or any landfill system and all. So there, in these all aspects, there is a need for an geo-environmental engineering. And also assessment of the pollutants being discharged in the soil deposits. So disposal, handling, and storage. So this all assessment should be taken care. So that can be easily, sorry, I'm taking the attendance. Yeah, so that can be easily taken care only if you know how to handle and how to dispose the hazardous waste and how to take care of the contaminated soil or contaminated site. Yes, and later on the second point is about process by which the pollutant travel in a geo-environmental geo-environmental areas, we can say, that is contaminant transport. And later on, how the contaminated soil is being formed, how that contamination has been transported. And later on, protection of the groundwater aquifers from the contamination of the contaminated soil. And the methods of cleaning these contaminated soils or the contaminated sites, that we say it as remediation. And the methods of creating some value added products like recycling and reusing the waste material as a raw material, right? So that's it. I will be stopping here. So scope of geo-environmental engineering is one of the important topic here. So that's why I will be discussing that in the next class. Yes, I just want to show you the question paper. This was just an this lecture was just to show you the syllabus content and the course objectives, course outcomes, and also the question bank prepared for this course. And also unit 1 I have started with an introduction with all basic aspects. So this is the September 2020, yes, I think September 2020 question paper. So you can just see, so since the complete, it's a theoretical subject, so he may be asking the questions directly. That, like here you can see, the discuss in detail the scope of geo-environmental engineering with clear illustrations. So that is, he has asked for 15 marks, and in the unit 1 itself is also asked the type of soil pollution and discuss the soil pollution, that is industrial effluent and solid waste, agriculture and urban activities. That is different types of waste production, I can say. And the same he has asked again here, write the types of waste and discuss the following. It is agricultural waste, biodegradable waste, biomedical waste, and chemical waste. Right? Yes. So another question paper I have here, December 2020. So here also you can see. So most probably he may ask the direct question. He may not ask in the other way or asking differently. So what are the source of contamination and discuss any two of them in this way. And again, what is the need of the characterization of a contaminated site and discuss that in detail. And again, various types of waste and discuss the sources of the different types of waste like biomedical waste, and write about the biomedical waste and how waste is recycled. So this just have shown you 1 or 2 questions which is related to unit 1. So in the same way, I'll be discussing at the end of the unit the previous year question paper and also the question bank related to that unit. So that's it, friends. So if you have any questions or if you want to ask anything, you can ask. I'll be allowing all you to unmute yourself. So as per the list I have got, so the number of students enrolled for this course are 25, right? So I've taken the attendance, and the attendance this will be posted in your ECAP, and whatever the materials related to the course will be shared in the Abhyas, so you can download it from the Abhyas. Okay, so thank you so much. So maybe the meeting is going to end now.